Welcome, learners. My name is Mr. Pochilola. Once again, your science teacher on this platform. I hope you have started your exams on a good note. Here at Black Slides, we continue wishing you the best. We decided to prepare this video lesson just to revise a paper from Southwest Education Division, in short, Swed. So this is a mock paper, physics paper 1. Welcome to Black Slides Online Secondary School. This is where you come and you revise the sciences and some on-demand subjects. If you are watching us on our YouTube channel, which is Black Slides, consider subscribing to the channel, hit the notification bell so that you get notifications every time we upload new material. You can also reach us on the number shared here. I think something is not alright. Supposed to be 098 and then the rest of the numbers 098. I think the 8 was omitted there. Or you can also contact us on via our email address, which is blackslidestutors@gmail.com. Welcome, learners. So this is physics paper 1 from Swed. I understand physics paper 1 is coming on Friday, just 2 days from today. And I believe this revision has come on time. Our assessment here has noted that this is a good paper because it covers a lot of key topics at MSCE. In other words, it covers a good ground in terms of syllabus coverage. It's a very important paper. So revise up to the end. Watch the video, taking notes where possible, verifying also using your calculators and others. Alright, so we wish you the best. Invite your friends. Share the video to your friends, wherever they may be, so that they can as well revise. Welcome, learners. Without your precious time, let's get down to the business of the day. Kindly pay attention to the tips as I bring them to you as we go through this paper. Welcome, learners. You can watch this video either as an individual or you can watch in your group, in your study group. You can play this on your TV if you have one, or you can play on your laptop or tablet and watch as a group, discuss, go through the solutions up to the end. Welcome, learners. Welcome to section A, which is 70 marks. A standard paper will have given you instructions here as to what you need to do, but I'm sure the instruction is for candidates to answer questions in the spaces provided. Question number 1. What is the difference between systematic error and random error? This is taken from measurements in Form 3. I'll be mentioning the topic from which the questions are taken. So this is Form 3 Physics. And it happens to be the first topic, which is measurements. So what is the difference between systematic error and random error? 2 marks. Right? So the question is just asking for a single difference. That means there isn't much to write here. All the same, the examiners were looking for any of the following differences. Systematic errors shift measurements consistently in one direction, either in positive direction or negative direction, with respect to 0. While random errors causes readings to scatter, both above and below the true value. It can be positive or negative. But a systematic error shifts measurements consistently in one direction. It can be positive throughout or negative throughout. But random errors will always cause readings to scatter both above and below the true value. That's one difference. By saying this difference, you have 2 marks. So 1 mark could come from systematic error shifts measurements consistently in one direction, 1 mark, while random error causes readings to scatter both above and below the true value. That's another mark, giving you 2 marks. Another important difference between the two is that systematic error arises from faulty instruments or incorrect calibration, while random error comes from uncontrollable small variations and human judgment. Random errors. This again is 2 marks. It has 2 parts. Each part is 1 mark. Systematic error can be reduced or eliminated by fixing equipment or fixing the method used, while random error can only be minimized by repeating measurements and finding the average. As a matter of fact, random errors are the only type of errors that can be minimized by repeating measurements and finding the average. So know the 3 differences so that you can give any 2 or any 1 for 2 marks. Calculate the actual reading of an ammeter with an error of minus 0.3 ampere that was used to measure the electric current of 1.3 ampere in an electric circuit. This is called a zero error. So we are asked to calculate the actual reading of the ammeter. If it has an error of 0 minus 0.3 ampere and a measured value of 1.3 ampere. So what was the actual reading? Right? So the instrument reading is basically equal to true value plus an error. So the true value here we are told is 1.3 and the error is minus 0.3. So just add the two. 1.3 add 0 minus 0.3. That's the same as 1.3 minus 0.3. So subtracting this would give us a reading of 1.0 ampere. So don't forget, when adding here, you have to add the whole value, the whole error with its minus. If this was positive, you would simply subtract. You would still get the same result. Welcome, learners. convert 450,000 nanometers to meters. This again is from Form 3 physics. From atomic code measurements, subtopic prefixes of SI units. Welcome, learners. So converting 450,000 nanometers to meters. Remember what a nano is. A nano is just 10 to the power minus 9. So we can write this. 1 nanometer. 1 nanometer is 1 times 10 to the power minus 9 meters. The nano is just 10 to the power minus 9. So what is 450,000 nanometers to meters? So 450,000 nanometers is the same as 450,000 times 10 to the power minus 9. This 10 to the power minus 9 is a nano n. So rewriting this number in standard notation, you have to shift 1, 2, 1, 2, 3, 4, 5. So this will be 4.5 times 5, 10 to the power 5. So this will be 4.5 times 10 to the power 5 times 10 to the power minus 9. Remember to express the 450,000 as in standard notation. So scientific notation. So this will be 4.5 times 10 to the power 5 times 10 to the power minus 9. So that will give you 4.5 times 10 to the power minus 4. You need to understand this very well. So we are saying that 450,000 is the same as 4.5 times 10 to the power 5. That's 450,000. Then this is multiplied by 10 to the power minus 9. Right, so multiplying 10 to the power 5 by 10 to the power minus 9 is basically 10 to the power minus 4. So the result is going to be 4.5 times 10 to the power minus 4. Welcome, learners. Therefore, 450,000 nanometers to meters is just 4.5 times 10 to the power minus 4 meters. Or if you like, you can write this as a decimal to be 0.00045, but it's recommended that you leave your answer in standard notation, like this, scientific notation. Welcome, learners. So I'm sure the 3 marks are coming from these 3 important steps. The examiners don't expect you to write a lot. It's just 3 marks. Question number 2. State the Archimedes principle. Archimedes principle is a simple statement that says when an object is fully or partially immersed in a fluid, it experiences an upward force, the force called upthrust, which is equal to the weight of the fluid displaced by the object. As simple as that. I don't expect anyone to miss this if it comes in an exam. It's like you're just defining a term. It's 1 mark. So when an object is fully or partially immersed in a fluid, it experiences an upward force, which is called upthrust, equal to the weight of the fluid displaced by the object. Explain using the principle here why a submarine is capable of sinking and floating in water. In other words, using Archimedes' principle, explain how a submarine ship sinks or floats on water. 4 marks. It is expected for you to raise 4 points at least. The number of marks indicate how many points you must raise in your answer. So first of all, you need to say that a submarine has what are called blast tanks that can be filled with water or air. That's 1 mark. So in order to sink, water is let into the tanks, which increases the submarine's total weight so that its weight becomes greater than the upthrust from the displaced water. As per Archimedes' principle, the net downward force makes it sink. So by saying this and this, you already have 2 marks there. In order to float, water is pumped out and displaced with air, replaced with air. This reduces the submarine's total weight so that its weight becomes equal to or less than the upthrust. By the end of the day, this will cause it to float. So the balanced or upward net force makes it rise and float. So 2 issues here, sinking and floating. Total mark, 4 marks. Give 2 factors that affect the magnitude of upthrust. Remember that upthrust is the force that a fluid exerts on an object immersed in it. So we are asked to give 2 factors that affect the magnitude of such a force. One of them is density of the fluid. Density of the fluid, the greater the density of the fluid, the greater would be the force exerted on the object by the fluid. Volume of the fluid displaced. The greater the volume of the fluid displaced, the greater would be the size of the upthrust and also the volume of the immersed part of the fluid. The greater the volume of the object immersed in the fluid, the greater would be the upthrust on the object. State the kinetic theory of matter. 1 mark. The kinetic theory of matter is a simple statement that says all matter is made up of tiny particles that are in constant random motion. That's all. 1 mark. There isn't much to say there. Explain in terms of the kinetic theory of matter why a balloon expands when it is heated. When a balloon is heated, it expands. Why does it expand? 3 marks, 3 points here. When heated, the air particles inside the balloon gain thermal energy, which increases their kinetic energy. These are keywords. So the air particles gain thermal energy, increasing their kinetic energy. Remember, kinetic energy is energy due to motion of particles. So the particles move faster and collide more frequently and forcefully with the inner walls of the balloon. This will lead to a condition whereby the gas pressure inside is raised, pushing the elastic rubber outwards until the internal pressure balances the external atmospheric pressure, causing the balloon to expand. 3 marks from the 3 points. Welcome, learners. Define the term liquid pressure. We shall define liquid pressure as the force exerted per unit area by a liquid at a given depth. And this is caused by the weight of the liquid above that point. It's liquid pressure. These are topics from Form 3. Calculate the height of a water tank if the pressure exerted by the water molecules at the bottom of the tank is 50,000 pascals, given that the density of water is 1,000 kilograms per cubic meter and G is 10 meters per second square. So here we are given data which we need to use. We have pressure of 50,000 pascals, which is a lot. This is the same as 50,000, 50 kilopascals, and the density of 1,000 kilograms per cubic meter. The acceleration due to gravity G of 10 meters per second square. So we are asked to calculate the height of the water tank. Recall that the liquid pressure is related to the density of the liquid, the acceleration due to gravity, and the height by this equation. This is density times acceleration times height. So making the height the subject to give us height equals to pressure divided by density times gravity. Just make h the subject, you give you this. So the rest is just substitution. Pressure is 50,000 pascals, density is 1,000, and G is 10. Just substitute to find h. So this is the information we are given from the data there. So all we have to do is substitute. So you substitute pressure at 50,000, density is 1,000, and acceleration is 10. So the height is going to be 5 meters. Give any two properties of vectors. First, recall that a vector is any quantity that has magnitude and direction. So we are asked to give any two properties for 2 marks. We are still doing Form 3 topics up to this point. A vector quantity has both magnitude and direction from the definition of a vector. So any quantity that has magnitude and direction is considered to be a vector quantity. 1 mark. So vectors also follow the triangle or parallelogram law of vector addition. They add according to specific geometric rules. These are the properties of vectors. 2 marks. Welcome, learners. Why is distance a scalar quantity while displacement is a vector quantity? This is a follow-up question from the previous one. Distance is considered to be a scalar quantity. Remember, scalar quantity is a quantity that does not have direction, but it has only magnitude or size. So distance is one of them. It's because distance only describes the total length of the path traveled. It has magnitude only and no direction, so it is a scalar quantity. 1 mark. On the other hand, displacement describes the shortest straight line distance from the starting point to the final position, and also includes specific direction. So it is a vector for that reason. Accurate deceleration of an athlete who dropped his speed from 60 meters per second to 40 meters per second in 4 seconds. Alright, so the formula for acceleration is just the same as deceleration. Remember, deceleration means slowing down, but it is still acceleration anyway. So to find acceleration, we take final velocity or final speed minus initial speed. So the final speed here is 60. Excuse me. The initial speed is 60 meters per second, while the final speed is 40 meters per second. And for this change to happen, it required 4 seconds. So dividing acceleration is going to be 40 minus 60 divided by 4. 40 minus 60 is minus 20 divided by 4 is minus 5 meters per second square. Don't forget, the negative sign means speed is decreasing. So the negative sign means that the speed is decreasing. So don't forget, to find acceleration, you take final speed. Here, final speed is 40 minus initial speed is 60 divided by time 4. This uses one of the Swed equations, which says that V is equal to U plus AT. So making A the subject from that will give us this. Describe any one application of radioactive substances in the food industry. In the food industry is which is the one that deals with food. So what is the use of radiation there? Nuclear radiation. Right, so in the food industry, gamma rays from radioactive sources such as cobalt-60 are used to kill bacteria, moths, and insects in food. That's an application of radioactive substances in the food industry. Gamma rays from radioactive sources. Typical example is cobalt-60 are used to kill bacteria, moths, and insects. Figure 1 is a diagram showing the radioactive substances labeled A, B, and C passing through a magnetic field. So we have a source here of radiation, and we have two magnets that are placed side by side. Remember that between the magnets there's a field there, magnetic field. So this region is called magnetic field. Identify the radioactive substance labeled A, the one that bends towards the negative, towards the south pole of a magnet. So before we come to this, we're still looking at question number 5. Describe any one application of radioactive substances in the food. So we said that gamma rays from radioactive sources. A good example is cobalt 60, are used to kill bacteria, moths, and insects in food. This extends shelf life. Shelf life is the duration, the time the food remains safe to eat, prevents spoilage, and also eliminates foodborne diseases without making the food radioactive. So 1 mark. Alright, back to question B, part B1. Identify the radioactive substance labeled A. So A is this one here. So A must be beta particles, beta radiation if you have to say that. The reason is because beta particles are negatively charged. Remember that so beta particles will bend towards the positive south pole of the magnet. Given two properties of the radioactive substance labeled B, take note that B is not deflected either towards south or towards north. So this must be gamma therefore. So we are asked to give two properties of gamma. Great. So gamma radiation has no electric charge, so it is not deflected by magnetic or electric fields, just passes through. By the fact that just passes through is never deflected either towards the north or towards the south pole, it means it's gamma. Another property is that it has very high penetrating power, meaning it passes through paper, aluminium, and can only be stopped by thick lead or concrete. So two properties, 2 marks. Explain how the radiation of the radioactive substance labeled C occurs. First of all, identify what C is. C is alpha, which consists of positively charged helium nuclei, which is emitted when an unstable heavy nucleus has too many protons and neutrons to become more stable, so it releases alpha. An alpha particle, these alpha particles made of 2 protons and 2 neutrons, reducing its mass and atomic number. The mass reduces by 4 and the atomic number reduces by 2. So being positively charged, it bends towards the negative, which is the north pole in the magnetic field. Welcome, learners. State the law of conservation of mechanical energy. Remember that mechanical energy is the total sum of potential energy and kinetic energy of the system. And is the law of conservation of mechanical energy is basically the law of conservation of energy itself. So in the absence of air resistance or other external forces, the total mechanical energy, which is the sum of potential energy and kinetic energy of a system, remains constant, which means energy can only be transferred or changes from one form to another. It is neither destroyed nor created. That's called the law of energy conservation. Calculate the height of a roof. If a stone falls from the top of the roof and hits the ground with a velocity of 15 meters per second, given that acceleration due to gravity is 10. Right. So by conservation of energy, it means potential energy, which is mgh, is equal to half mv squared, half of the mass, times the square of its velocity. This must be an equals sign, as well as here. So mgh equals to half mv squared. Simplifying both sides, dividing both sides by m, and making h the subject. Making h the subject will give us h equals to, the height equals to v squared, the square of the speed divided by twice the acceleration due to gravity. Right, so substituting into the equation, speed we are told is 15, and then acceleration due to gravity is 10. So substituting and simplifying accordingly will give us h equals to 11.25 meters. Please verify these calculations using your calculator. Don't just memorize the answers, the solutions, because these are not the questions you are going to meet in your exams on Friday. Just guiding you through in case you meet something like this. You should be able to do without problems. Welcome, learners. Define frictional force. Recall that frictional force is the opposing force that acts between two surfaces in contact and opposes the relative motion or tendency of a motion between them. So it's an opposing force. Figure 2 is a diagram showing a block of wood of mass 30 kg being dragged by a force of 40 newtons to an angle of 60 on the horizontal surface. Calculate the coefficient of kinetic friction. So in order to calculate the coefficient of kinetic friction, you shall need the formula. This is called the kinetic coefficient of coefficient of kinetic friction. So it is found by taking the horizontal force divided by what is called the normal force. Remember that the normal force is just the mass times the gravity, but because we have this, here we shall also need to find the vertical component of this force, so that this will give us the net vertical component. To find the horizontal component or the horizontal force, simply take one of the trig ratios to be 40 multiplied by the cosine of 60. That's going to be the horizontal force, the force in the horizontal direction. The normal reaction is going to be 30 times 10 minus the vertical component of this force, which is 40 sine 60. If you do your calculation here properly, 4 cos 60 must be 20, and 10 minus 10, 30 times 10 minus 40 sine 60 is going to be 20 or 265.36. So the coefficient of kinetic friction is going to be 0.075. Welcome, learners. This is Black Slides Online. State length law. Length law states that the direction of an induced current is such that it opposes the change in magnetic flux that produced it. Don't confuse this with Faraday's law, because both laws apply to induction, electromagnetic induction. But the difference between Lenz's law and the Faraday's law is that Lenz's law applies to current, while Faraday's law applies to the magnitude of the induced EMF. So take note. Also review the Faraday's law so that you don't miss that. Give any two ways of increasing the strength of an electromagnet. Well, there are many ways. The examiner is just asking us for any two marks. So one way to increase the strength of an electromagnet is to increase the number of turns in the coil. The more the number of turns, the more the turns in the coil, the greater will be the magnetic force or the strength of the electromagnet, one of them. Also increase the current flowing through the coil. If you say increase the number of cells, that's not really considered to be it. The target must be to increase the current. You can also do the same if you say increase the voltage, which is the energy, which is the energy used to drive charge through the coil. And also make sure that you use a soft iron core. Calculate the angular velocity of a particle that sweeps through an angle of 90 degrees at the center of a circle in 4 seconds. Remember, angular velocity is simply the angle in radians divided by time. So the angle in radians, just change the 90 degrees to radians. Remember that 90 degrees is the same as pi over 2 radians. So this is going to give you the angle swept in radians. So dividing the angle, this is what you call it, the angular displacement. Yes. So angular displacement. So angular displacement divided by time will give you angular velocity. So in this case, you have 1.57 radians divided by 4. If you do your calculations properly, you end up getting 0.3925. But you have to be careful with significant figures. Welcome learners. It will be safer to keep this to two decimal places. Or if you want, just one decimal place, because each of these numbers, the given numbers, are to one decimal place. I mean, one significant figure, sorry. These numbers are to one significant figure, therefore it is appropriate to leave the answer to one significant figure as well. So I would prefer if this was 0.4. Figure 3 is a diagram of a wave. Identify the type of wave. This is basically a longitudinal wave. Remember that a longitudinal wave consists of troughs and consists of rarefactions and compressions. Give any two properties of the wave shown. One of them is that the particles of the medium vibrate parallel to the direction of the wave travel. Right? Unlike transverse waves are the ones that are given by this thing. Okay. So one of the properties of longitudinal waves is that the particles vibrate parallel to the direction of wave travel. And other than that, longitudinal waves consist of regions of compressions and rarefactions instead of crests and troughs as it happens in transverse waves. Welcome learners. Calculate the focal length of a convex lens when an object placed at a distance of 6 centimeters from the lens produces an image at a distance of 12 centimeters away from the lens. So you have to recall the wave equation. This is called the lens formula, sorry. This is the lens formula. So the lens formula states that 1 over focal length is equal to 1 over object distance plus 1 over image distance. Know these terms and the equation. So substituting the values, we are told the object distance is 6 and the image distance is 12. So 1 over f is equal to 1 over 4. Therefore, f, which is the focal length, is equal to 4 centimeters. Welcome learners. Give any one device that could be used to detect the infrared radiation. Remember that infrared is just the heat energy, and it belongs to the electromagnetic spectrum. I think it's number 5 from gamma infrared. This is heat, like the heat you get from the sun, the heat you get from hot objects such as metal, glowing metal, which is getting hot. Heat you get from ambaula, it's called infrared. So what device can be used to detect infrared? Infrared can be detected by using what is called a thermocouple, an infrared camera, thermometer with blackened bulb and photocells. define the term doping. Doping in relation to semiconductors. This is from 4 topic. I think most of the questions we are meeting now are from 4 questions. Define doping. So doping is defined as the process of adding small controlled amounts of impurity atoms to a pure semiconductor to increase its electrical conductor. Remember that pure semiconductors can have their conductivity enhanced by raising their temperatures as well as by adding some impurities, which can be group 3 or group 5 elements. Figure 4 is a diagram of an electric current, an electric circuit showing semiconductor devices labeled M and N. So we have M and N there. Identify the semiconductor devices labeled M and N. So M is just a transistor, and the N is a diode, semiconductor diode. So know these things very well, the symbols and their meanings and the like. I'm sure you know what this is. This is a bulb, this is a resistor, and that's a battery. Explain in terms of the band theory why an increase in temperature of the device labeled N improves its electrical conductivity. Why a diode improves its conductivity when heated. Great. Alright, so the examiners are looking for the following explanation. So when the temperature is low, electrons in the various band of the semiconductor are bound, and the energy gap between the various band and the conduction band is too large for electrons to jump easily. So when temperature rises, electrons gain thermal energy, which translates into gain of kinetic energy. Right, so this allows more electrons to cross the energy gap, which is also called the forbidden gap, from the valence band into the conduction band. So more free charge carriers, electrons and holes become available to conduct electric current. So this way, as the number of charge carriers increases significantly, the electric conductivity of the diode also improves. 4 points for maths. Welcome learners. My name is Mr. Pochilora, your teacher. State Charles law. Charles law is to do with gas laws. One of the gas laws states that at constant pressure, the volume of a fixed mass of gas is directly proportional to its absolute temperature, or Kelvin temperature. Meaning as the temperature increases, the volume of the gas also increases, possibly because of expansion and the like. Keeping only true when gas pressure and mass are kept constant. Calculate the final volume when a temperature of, Alright, calculate the final volume when a temperature of 20 cubic centimeters of oxygen gas is raised from 27 degrees Celsius to 77 degrees Celsius, assuming the change in temperature is occurring at 1 atmosphere. So let's check what data we have here. Right. So the data we are given here is the volume of the gas. This must be the initial volume. We also given the initial temperature and final temperature. So we are asked to find the final volume of the gas under these conditions. Right, so Charles' law, according to Charles' law, the initial volume V1 divided by the initial temperature T1 is equal to the final volume V2 divided by the final temperature T2 at constant pressure. And this is true when the temperatures are in Kelvins. So you change each one of these temperatures into Kelvins. So we have 27 plus 273, which is 300, and then change the 77 degrees Celsius by adding 273 again to give us 350 kelvins. Substituting in and simplifying in this equation shall give us the final volume as 23.33 cubic centimeters. Explain why Charles' law could be applied in flying a hot. Explain how Charles' law could be applied in flying a hot air balloon. Charles' law applies a lot in a hot air balloon in the following manner. So when the air inside the balloon is heated, its temperature rises. Remember that temperature is related to heat. Alright, so the more the heat, the higher the temperature. Alright, so by Charles' law, the air expands, so some air escapes from the balloon. This reduces the mass and density of the air inside the balloon, making it less dense than the surrounding cooler air. 3.3 max. Welcome, learners. So the upthrust from the denser outside air becomes greater than the balloon's weight, causing it to rise and float in the air. That way, Charles' law is at work. Welcome to section B, where you have to answer some restricted questions, restricted essays. Here you have to do a little more of writing. Then section A. Describe an experiment that could be done to measure the time interval using a pendulum. So a pendulum can be used. It consists of a mass bulb, and a string, which is fastened at some point, the clamp. Describe an experiment that could be done to measure the time interval using a pendulum. So suspend a bulb from a fixed point with a light string. Measure its length. Remember, a pendulum consists of string and a bulb. So suspend a bulb from a fixed point with a light string. Measure its length. Displace or push, or the better way is to displace the bulb slightly at an angle most closer to or less than 10 and release it to swing freely. Alright, then use the stopwatch to measure the time taken for 20 complete oscillations. Divide the total time by 20 to get the time for one full swing. So that's how you do it. So multiply the period of the number of swings to get. Multiply the period. What you get here is the period, by the way. Remember, period is time taken to complete one oscillation. So multiply the period by the number of swings to get the required time interval. Measure the diameter using a pendulum. 5 points, 5 marks. Describe how a shrink fitting method could be used to produce a tight fit. This is the application of the thermal properties of matter, or thermal expansion and contraction. So describe how shrink fitting method could be used to produce a tight fit between more metals. Alright, so what needs to be done is that the outer metal ring or housing is heated strongly, causing it to expand and its inner diameter to become tightly larger. So while still hot, the inner shaft or rod is easily inserted into the expanded opening. Effectively, the assembly is left to cool down gradually to room temperature. Alright, as it cools, the outer part contracts back to its original size. Once it fully cools, it shrinks tightly around the inner part, creating a very strong permanent tight fit. Welcome learners, 5 marks, 5 points, 5 marks. Each correct point is 1 mark. And also take note that these points are in a sequence. You say first thing first, like that, up to the end. Question number 5. Describe how a drying machine uses the principle of circular motion in order to dry the wet clothes. Dry machine. Remember, dry machine has a drum. So it is that which is mostly and together with other parts used to dry clothes. The dry machine. So the drying machine, the drum holding the clothes spins rapidly in a circular path. Alright, so the spinning creates a centripetal force directed towards the center of the drum. Remember that centripetal force is the center seeking force of a body that is moving in a circular path. Alright, so this force acts on the clothes but not on the water droplets. As a result, the water droplets move in a straight line, tangentially through the holes in the drum due to inertia. Right, the water flies off radially in all directions outwards, leaving the clothes drier. Welcome learners, my name is Mr. Bochilola, your teacher. With the aid of a well-labeled diagram, describe how a simple mercury barometer works. Remember that a simple mercury barometer is used to measure pressure, especially atmospheric pressure. So the diagram of a simple mercury barometer looks like this. It has a tank, this bit here, which is called a reservoir. It's also called a cistern. It's a dish containing mercury, basically. So the dark substance inside it is mercury. And it has a glass which is inverted, turned upside down upon being filled with mercury. The top part here is empty, it's a vacuum. There's no air above the mercury here. And then we have a scale. So at least show any 3 paths. It's recommended that you show any 3 paths on any diagram, on a question that requires a diagram. By indicating the 3 paths, you have 1 mark. And the diagram also may be 1 mark, a total of 2 marks. So I feel that the question was underscored. TAU is supposed to be greater than 5 marks, but that's fine. So with the aid of a well-labeled diagram, describe how a simple mercury barometer works. So this is the diagram. Right, so fill a long glass tube, this one, fully with mercury. Close the end. You have to be careful because mercury is toxic. And invert it into a mercury dish. So invert it, you need to turn it upside down, like shown here. So mercury level drops, this level drops, creating a vacuum at the closed end of the tube. So there's a vacuum over here. So atmospheric pressure pushes down on the mercury surface in the dish. So atmospheric pressure is going to push this down. The mercury down. This one. It's open to the atmosphere, so the weight of the air is going to push on this. Alright, so this push pressure supports the mercury column inside the tube. Eventually, the height of the column, mercury column, equals the surrounding atmospheric pressure. That's how a simple mercury barometer is used to measure atmospheric pressure. Atmospheric pressure, standard one is 760 millimeters, which is also the same as 76 centimeters. Welcome, learners. Welcome to the last question. Describe the motion of a metallic ball that is falling in a tin containing oil. This is about terminal velocity. So describe its motion. In other words, you are answering a question that says, how does a metallic ball falling in a tin containing oil achieve its terminal velocity? Right, so initially the ball accelerates downwards due to its weight, which is greater than the upward viscous drag and the upthrust from the oil. Right, by saying that you have 1 mark. As speed increases, the viscous drag force increases also, so the net downward force and acceleration decrease. Welcome, learners. So the ball continues to move downwards with decreasing acceleration, so its speed rises at a lower rate. Eventually, what's going to happen is the sum of the upthrust and drag becomes equal to the weight of the ball minus eventually the sum of the upthrust and drag becomes equal to the weight of the ball. So the net force becomes 0. Alright, so the ball then moves at a constant maximum speed. It's called terminal velocity for the rest of its fall to the bottom. Welcome, learners. With the aid of a well-labeled diagram, describe how a setup transformer works. Remember that a step-up transformer has fewer turns in the primary coil than in the secondary. So when you're drawing, make sure there are few turns this side and more turns there. This is called a step-up transformer. There are fewer turns here and more there. Step up means it raises the input. The output voltage is greater than the input voltage. That's called a step-up transformer. Alright, so it has fewer turns in primary coil here and more turns in the secondary coil over here. So the AC input produces changing flux in the soft iron core. The AC input, remember that AC alternating current is preferred to direct current because AC must produce changing magnetic flux. Changing magnetic flux. Right? DC cannot do that. So you need AC for that reason. So AC input produces changing magnetic flux in the soft iron core. So flux links to the secondary coil. Flux links to the secondary coil and induces a higher voltage across the secondary coil. So a higher voltage is induced over there. All right. So the voltage ratio equals to the turns ratio, meaning that the voltage in the secondary coil, so is E over the voltage in primary coil. This is called voltage ratio. Is equal to the number of turns in secondary coil divided by number of turns in primary coil. That's what that means. Okay. So from this it will be found that the voltage in the primary coil, in the secondary coil, is greater than in primary. That's how the step-up transformer works. Welcome learners, wishing you the best as you